Yo, what's up, everybody? Here's the Unit 3 review for our MCLA class. On problem number 1, it says f of x equals this. Then what is f of negative 8? Well, that means I'm going to be replacing x with negative 8. So the way I'll write that is f of negative 8 equals, and remember that f is the name of the function. That's like saying y equals. So don't stress out when you see f of x. That's just like saying y equals. Your output is blah, okay? So f of negative 8 is, and the way we find that is by plugging in a negative 8 for x. So it's going to say negative 3/4. And instead of x, I'm going to leave it blank for right now. So negative 3/4 something plus 5. So in that spot where x used to be, we're replacing it with a negative 8. Awesome. So that's what we do. And some of y'all don't love fractions. I'm going to do this with a fraction. But if you don't love fractions, you could look at that negative 3/4 and call that negative 0.75 if you would like. And the way you can do that on the calculator is you can say, hey, what's negative 3 divided by 4? And you would get negative 0.75. So if you want to treat that like a negative 0.75, you can. I'm going to do it with fractions. And when I use fractions, I do the top number, negative 3, times that whole number, negative 8. So negative 3 times negative 8 is a positive 24. And I still have to divide by that bottom number. So I'll do that in my next step. All right, I'll just bring down the name of the function there, f of, and we're using negative 8 as an input. So first step's done. Now we can finish up with that fraction by saying 24 divided by 4. 24 divided by 4 is 6. So I'll say f of negative 8 equals 6 plus 5. Or f of negative 8 equals 11. So what that means is my function f, when it has an input of negative 8, will equal 11. We'll have an output of 11. So that's what all of that notation means. That's our function notation. Number 2 is kind of similar, but a little bit different. It's still dealing with function notation, but this time, instead of plugging a number in for x or in for a or whatever, we're saying that the function equals negative 5. So it's going to be a little bit different. Let's do this in a different color. So they are replacing x with a. So in place of x, they're putting a. No big deal. So I'll call it g of a. And they're saying that g of a, this right here, g of a, they're saying that's going to be replaced with negative 5. They're saying g of a is equal to negative 5. So I'll write negative 5 equals 2/3 times a minus 7. So I have a little two-step equation. You guys know the first step is to add 7 to both sides. And negative 5 plus 7 is a positive 2. And I have 2/3 a left, and the minus 7 and plus 7 canceled out. Now, we could solve this in a couple different ways. I've always taught to get rid of that times 2/3, we'll multiply by the flipped version, the reciprocal of 2/3, 3/2. And that's one thing we could do. But I've also seen other students say, hey, I'll get rid of that divided by 3 first by multiplying by 3. So you could totally do this. So now instead of, on the left side, I'll have 6. And on the right side, instead of 2/3 a, the 3's canceled out, and I just have 2a. So if you're not super great with fractions, maybe that's the way you want to do it. And then the last step to figure out what a is, divide by 2. And a equals 6 divided by 2 is 3. So cool. So a little bit different process because on this one, I wasn't replacing x with a number. I was seeing what x or a would have to be when the function was equal to -5. So a little bit different setup. We had to make the function equal to -5. All right, number 3, Marquise buys a meal card for his college cafeteria. The balance, so this is the amount of money he has on his meal card, and M is the amount of months, okay? What is the balance? So what does B equal after 20 meals? So when M equals 20, what is B of 20? So the correct way to write this is B of 20. So the balance when he's had 20 meals is equal to our function's 500 minus 5m, but we're replacing m with 20 because he's eating 20 meals. Hopefully not in one day. That was bad. A little math, 5 times 20 is 100. So, and then 500 minus 100. The balance after 20 meals is equal to 500 minus 100, $400. Cool. So that 3A was a lot like number 1, where we were replacing the input, in this case M, with a number. Now 3 part B says after how many meals will the balance will B equal 0. So in this case, we want his money, his balance to equal 0. We want B of M to equal 0. So instead of plugging a 0 in for M, I just want to see when the total is equal to 0. So I know that B of M equals 500 minus 5m, and I want to know when that total is going to be equal to 0. A little 2-step process. Maybe let's move the m's to the other side. I think that'll look better. All right, so after I do that, now I have 5m on this left side. And on the right side, the minus 5m and the 5m cancel out, just equals 500. 1-step equation. And m equals 500 divided by 5. So he can eat 100 meals before he runs out of money. All right, this one's pretty straightforward here. They're either linear or they're nonlinear. Well, this one's an absolute value, so that's nonlinear. This one is in standard form, so remember that standard form ax plus by equals a number. And standard form is what we use for linear. Now you know that if you have an x to the first power, then it's going to be linear. Unless it has these absolute value bars, right? The third one has an x squared on it. So that's nonlinear. In fact, that is quadratic. The next one has an exponent of x. So that's another nonlinear. That's an exponential. And then the last one is written kind of in slope-intercept form, and I have an x to the first power. So that is a linear. So just to recap, we had an absolute value. We had a linear in standard form. So we liked that one. We had a quadratic, because it was x squared. We had an exponential, because it was some number, in this case 5, with an x as the exponent. And the last one was good. It was a linear, and it was written in slope-intercept, kind of. All right, number 5. Oh man, we could do this in a couple different ways. We could graph it using the table, or we could just graph it because we're smart. Let's start by just graphing it because we're smart. I'm going to have a b. Remember, y equals mx plus b. I'm going to begin, I have a y-intercept at positive 3. So I'm going to put a dot here for my y-intercept at positive 3. That's where you begin, get it? B for begin. And then I'm going to move, m for move, that's our slope. I'm going to move negative 1 over 2. So that means down 1, right 2. I always move to the right. And the negative tells me that I'm moving down. So I'm moving from this starting point, I'm moving down 1, negative 1, and right 2. And I'll put a dot. I'll do it again. Down 1, right 2. Down 1, right 2. If you want more dots, go the other direction. Go up 1, left 2. Up 1, left 2. But you said always go to the right. You want to start by going to the right, but then when you want more dots, go to the left. And it better make a straight line. There it is. Cool. Now, I could have thrown those points into the equation here. And if I did that, that would be, oh gosh, negative 1/2 times negative 4 plus 3. I'm going to go through the math kind of quick because we ain't got all day. Negative 1/2 times negative 4. Well, they're both negative, so I know it's going to be a positive. And half of 4 is 2. So it's going to be 2 plus 3. It's going to be 5. The next one's negative 1/2 times negative 2 plus 3. Again, a negative times a negative is going to be a positive, and half of 2 is 1. 1 plus 3 is 4. Man, I know this is my starting point, so I don't really have to do any work. I know that's going to be 3. And I'm starting to notice a pattern. 5, 4, 3. I bet the next one's going to be 2. I bet the next one's going to be 1. And if I did the work, I'd see that that pattern was good. Yeah, because it's going to be a negative 1. Half of 2 is 1, and it's going to be negative. So negative 1 plus 3 is 2. So my pattern checks out. It's all good. I should have written it here. 5, 4, 3, 2, 1. And then I'll notice that the points, the coordinates, that would have been negative 4, comma 5. And I'll notice that that kind of matches with the points that I'd have. That was negative 4, comma 5. Negative 2, comma 4. Negative 2, comma 4. So if I do it right, the table should match our graph. On the next page, what is the slope, coordinates of the x-intercept, and coordinates of the y-intercept for this equation? Well, this is written in slope-intercept form, so I like that. Y equals mx plus b. So I can very quickly pick out the slope. Slope's 1/3. Nice. I can very quickly pick out the b, which stands for y-intercept. So I know the y-intercept is negative 12, or 0, negative 12 is how we would write it. Now, the one that's going to require a little bit of work is the x-intercept. To find the x-intercept, we have to make the y 0. All right, or in this case, p of x, we'll have to make that 0, because p of x is like y. So it's going to say 0 equals 1/3 x minus 12. It's a two-step equation. Move that 12 over by adding 12. 12 equals 1/3 x. And then I can undo the fraction by multiplying by the reciprocal. The reciprocal of 1/3 is 3 over 1, or just 3. So that makes that cancel out. It was the reciprocal, so makes it go away. So I have x equals 3 times 12 is 36. So my x-intercept is going to be 36, comma 0. All right, this one's written in standard form. So it's going to be very easy to pick out the x and y-intercept, but it's going to be kind of a pain in the butt to pick out the slope. So with standard form, remember what I told you, when you want to find the x-intercept, make y 0. When you want to find the y-intercept, make x 0. So if I want to find the x-intercept, I'm just going to be like, all right, y, you're worth 0. So that's 5 times 0. It's a one-step equation. 2x equals -7. So the one step is to divide by 2. And x equals -7 halves. -7 halves. I'll do the same thing for the y-intercept. But for the y-intercept, I'll make x equals 0. So it'll be 2 times 0, 0, plus 5y equals -7. I don't need that 0 there. It doesn't make a difference. And it's a one-step equation. Divide by 5. And y equals -7/5. And now we can find the slope. But to find the slope, we've got to take this and put it into slope-intercept form. So I want that to be a y equals mx plus b. So I've got 2x plus 5y equals -7. And I eventually want that to be looking like that. So the plan here is I need to move the x's. It's always the same 2 steps. You move your x's over, you divide by the number in front of y. So move the x's over. Bye-bye. 5y equals, remember, you can't combine those because they're not like terms. So it's just going to say -2x and -7. You can't combine them. You can't call it -9. Don't do that. All right, and then the last step, divide by the number in front of y. All right, so then we end up with y equals -2/5 x minus 7/5. So not only do I see what my slope is, not only do I see what my slope is, the m, the slope, -2/5, but it also verifies that my y-intercept was -7/5. So that tells me, hey, I know I got that part right. All right, my friends. So to find the slope, we had to put it in y equals mx, y equals mx plus b form and figure out what m was. But to find these other guys, we just had to make the y 0 or make the x 0. In the next one, what is the slope of the line? Okay, this is straight slope formula. Remember, the slope formula is your change in y, so y2 minus y1, divided by your change in x, x2 minus x1. If we were looking at a graph, it would be our rise over our run. All right, and it's the same thing. So if you need to, label them x1, y1, x2, y2. And then when you plug them in the formula, you'll be like m equals, and you just do y2 minus y1, so -1 minus 5. You'll do x2 minus x1, so 2 minus, be careful with your signs here, that's a -6. So when you see those two negative signs right up against each other, make a big positive sign out of it. So this really says -1 minus 5, -6, and 2 plus 6, 8. So that's a good answer, but we could also reduce our fraction. And we would reduce it by dividing what goes into 6, what goes into 8. 2 goes into both of those numbers. So divide them both by 2, and you get -3/4. So our slope, m equals -3/4. All right, and then this one over here is the same deal. We could label them x1, y1, and x2, y2. And I could run through the slope formula, y2 minus y1. So in this case, it's -6 minus 4. And then x2 minus x1, so -7 minus -3. Again, be careful with your signs. I have two negative signs pushed up against each other, so I'm going to make that a big plus. And I've got -6 minus 4, which is -10. Over -7 plus 3. So I'm -7, and then I go up 3. So then I'm only at -4. And they're both negative, so I know that my answer is going to be a positive 10/4. And we could reduce that fraction by saying, hey, what goes into 10 and goes into 4? The number 2 goes into 10 and 4. So divide them both by 2. And you get 5/2. So m equals 5/2. All right, on to the next page. Okay, this next page is huge, man. There's a lot going on here. It all starts with this function, d of w equals 66 minus 2w. It's talking about a lake, and the lake is drying up, and the depth of the lake is decreasing. So I bet d stands for the depth of the lake. And I bet w stands for weeks, because it says that. All right. So if I graphed it, well, I'm going to just throw down a quick sketch of the graph. I'm not going to take a lot of time here. I know that at t equals 0, so at 0 weeks, when we started collecting this information, the depth of the water was 66. And then I see here this negative 2w. That means every week the depth of the water goes down 2 inches every week. So in 1 week it'll go down 2 inches. In 2 weeks it'll go down another 2 inches. And it'll keep going down, 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 down until I get to this point where we're out of water. So how many weeks would it take for the lake to dry up? Well, you're smart people. You could probably figure it out without math, or without actually writing down math. Like, all right, I want the lake to dry up. Well, that's going to take, let's see, it started at 66 and it decreases by 2 each week. So you probably just took 66 and divided it by 2. That's what y'all did in class. And you knew that it would dry up after 33 weeks. And you're right. Cool. So on this graph, not only do I see my y-intercept, I also see my x-intercept, and I know what my slope is. I know how far it's going down each week. It's going down by 2 each week. So we should have everything we need to answer all these questions. What is the slope of the graph? Well, the slope of the graph it's going down 2 each week. The slope is negative 2. Include units. Okay, so it's going down 2 inches for every 1 week. If you like fractions, you can say it's negative 2 over 1. It's going down 2 inches every 1 week. What is the real world meaning? Well, the depth of the pool, the depth of the lake, sorry. And I'm going to say decreasing because we had a negative slope by 2 inches every week. What are the coordinates of the x-intercept? Okay, the x-intercept, we found that. It was over here on the x-axis. The coordinates were, well, it's an x-intercept, so the x-coordinate was 33 and the y-coordinate is 0. It doesn't say use units, but if I was using units, it would be weeks. And the meaning of that was it took 33 weeks. At 33 weeks, the pool is out of, the lake is out of water. The lake is empty. The lake is dry. The lake has 0 inches of water. All right, what are the coordinates of the y-intercept? Well, we see that right here. The coordinates of the y-intercept on the y-axis is 66, but I have to write it as coordinates, so it's going to be 0, 66. And if it asks for units, I'd say it's inches. And the real world meaning was the lake started with 66 inches of water. The lake had 66 inches, had a depth of 66 inches. At the beginning, at the starting point, at t equals 0, at 0 weeks. What is the domain? All right, well, the domain, we're going to come back to our x-axis because domain is the x values. So let's see how far our domain goes. It goes from 0 to 33. So our domain is 0 to 33 weeks. It's not going to go it's not going to go left of 0 because you're not going to have negative weeks. It's not going to go past 33 because we're not going to have negative water. So 0 to 33 makes sense, from 0 to 33. Next is the range. The range is the y-axis. So what is the range? That's our y's. So let's look at the y-axis. The y-axis goes from 0 to 66. The most water we ever had was 66, and we're not going to go past 0 because we're not going to have negative water. So you write it from lowest to highest. That's why it's 0 to 66. And that's inches of water. Nice. All right, up next, we're going to write some equations of lines. We got this. This is using point slope form, so that's y minus y1 equals m times x minus x1. And to do this, we're going to substitute all the stuff that I had in red here. We're going to replace, because this is x1, y1, and this is our slope m. So those values are going to replace those letters I had in red. So the y is still going to be y minus, but I'm replacing y1 with this 3 here. Equals, all right, our m was negative 3/4, x minus, and I'm replacing that with our x1, which is negative 8. I do see two negative signs up against each other, so I'll change that to a big plus. So what I really have is y minus 3 equals negative 3/4 x plus 8. That would be cool, but it says it wants it in slope-intercept form, so I'm going to have to do a couple things. First, I'm going to have to distribute. So I'm going to take this, I'm going to finish my work over here. So y minus 3, and let's distribute, negative 3/4 x. And so negative 3/4 times 8, you could use your calculator, or you could just be like, all right, 8 times 3 is 24, it's negative, so negative 24. And the bottom is a 4, so I'll have negative 24 over 4. I could clean that up too. Let's clean that up. 24 divided by 4 is 6. All right, that looks better. And then the last step is to move that minus 3 over by adding 3. So y equals negative 3/4 x, negative 6 plus 3 is negative 3. All right, the next one is very similar, but we don't know the slope. So I've got to use these points, x1, y1, x2, y2, and I've got to find the slope first. So m equals, what's that, negative 5 minus negative 1 over negative 2 minus 4. Two negative signs pushed up against each other, change it to a plus, negative 5 plus 1 over negative 2 minus 4. Do the math, negative 5 plus 1 is negative 4, negative 2 minus 4 is negative 6. A negative over a negative makes a positive, and so I have a positive 4/6. If we can reduce that fraction, we should. We can. 2 goes into both of those numbers, so divide them both by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So our slope is 2/3. So now I'm going to do just like I did on the previous question. I'm going to use point slope form, y minus y1 equals m times x minus x1. I'm going to be replacing those things with the values that are in the problem. So y minus, in the problem, y1 is negative 1, m is 2/3, and x1 is 4. So I got those values from here and the slope that we found. Two negative signs pushed up against each other. Let's make that a plus. And it looks like that. Let's distribute. So it's going to say, I'm going to move my work over here. It's going to say y plus 1 equals 2/3 x minus, ooh, gross, 4 times 2/3. Well, 4 times 2 is 8, so it's going to be 8/3. Gross. Now I need to add 1 to the, or sorry, I need to subtract 1. So it's going to be y minus 2/3 x. Okay, this is not fun. Fractions. Did you know that -1 is the same thing as -3/3? You could do that, make a common denominator, or you could use your calculator. So -1 is like saying 3/3. And I've got -8 minus 3 is -11 thirds. You could also use your calculator. All right, now we got Juanita in her shoes. Write an equation to relate her pay in dollars. Oh, so if I want to write an equation, I need the slope. So I know that Juanita sold 30 pairs and got paid $350. And then she sold 40 pairs and got paid $400. So I need to see what her rate was per shoe. So I'll do that by calling this x1, y1, x2, y2, and I'll find the slope. So the slope, remember, is y2 minus y1 over x2 minus x1. What's that? 50 over 10, so 5. She makes $5 per shoe. M equals 5. So I know that M is 5, and I know that a point, I could use the first point. 30, 350. And I could write that equation using point slope form just like in the previous question. Y minus 350 equals M times X minus 30. So just like the previous two questions, except for Juanita was here. Let's distribute. All right, and then let's subtract add, because it's already subtract. Let's add that 350. When I do that, I got y equals 5x. Negative 150 plus 350 ends up being a positive 200. Remember, x is shoes, so maybe I should have used an s for that. And y would be how much money she made. Okay. What is she paid if she sells 50 pairs of shoes? Well, that would be a 50 for x. So y equals 5 times 50 plus 200. It's 250 plus 200. Juanita would make $450 if she sold 50 shoes. All right, and if she wants to be paid, all right, she wants her output, her Y, to be $1,000. She wants to make $1,000. How many shoes is she going to have to sell? Oh, I used S. Let's use X. So it is a two-step equation. Subtract the 200. Boop. That's $800 equals 5X. Divide by 5. And oh gosh, 800 divided by 5 is, I think it's 160. Check my answer because I don't have a calculator on me. So she'd have to sell 160 pairs of shoes. All right, guys, last page here. Write a function in slope-intercept form for the table. Well, to do that, I need the slope. Remember that the slope is found by doing y2 minus y1. So be careful because your table has the y's on the bottom. So this would be y1, y2, x1, x2. And I could have picked any points, but I'm just going to go with the first two. So my slope is going to be 19 minus 25 over negative 6 minus negative 10. Two negative signs pushed up against each other. So my slope is going to be 19 minus 25 is negative 6. And negative 6 plus 10 is 4. Reduce the fraction. Divide them both by 2. You get negative 3 halves. So my slope is negative 3 halves. And I'm just going to use this first point. So when I write my equation using point slope form, it's going to say y minus y1, which is 25, equals m times x minus x1, which is negative 10. Two negative signs, make it a positive. Distribute. Negative 3 times 10 is negative 30 over 2. Clean it up. 30 divided by 2 is 15. And lastly, add that 25 over. And I get y equals negative 3 halves x. Negative 15 plus 25 is a positive 10. What is the value of f of negative 20? Well, just drop. See, remember how if it's in the parentheses, that's your input. So put a negative 20 in there. Y equals negative 3 halves times negative 20 plus 10. Negative 3 halves of negative 20. It's a negative and negative, so it's going to be a positive. And 3 times 20 is 60, so it's going to be 60 halves plus 10. We can clean it up. 60 halves is really just 30 plus 10. And 30 plus 10 is 40. So y equals 40. And the best way to write this would be to say, hey, when I have an input of negative 20, that's going to equal 40. So that's a good way to put it. They used f, function notation, so I could have written f of negative 20 equals 40. These are all good answers. And last up, for which value of x does f of x equal negative 50? So in this case, we're not plugging in a negative 50 for x. We're saying the function equals negative 50. So my function, which was, I lost it. Oh, right here. My function, negative 3 halves x plus 10, is supposed to equal negative 50. Couple steps, subtract 10. Negative 3 halves x equals negative 60. And then remember, to get rid of a fraction, you multiply by the reciprocal. So let's multiply by the flipped version of that. So instead of negative 3 halves, we'll have negative 2/3. That's how we get rid of a fraction. X equals, and remember, a negative times a negative is a positive. That's going to be 120 over 3, and 120 divided by 3 is 40. So that'll happen when x equals 40. Yeah. All right, guys, I know some of my work at the end was kind of fast, but I had to finish it before the next class, which is in 2 minutes. So I hope you learned something. See ya.